In this video, we explore different ways of identifying equivalent fractions. That's fractions that in numbers might look different, but when you look at what they're worth, you can see that they're worth exactly the same. We have 2 pies. The one on the left is divided into 6 equal pieces, and the one on the right is divided into 12 equal pieces. And if we take 2 of those 12ths, you can see that they're exactly the same as 1/6. So what's happened here is with 1/6, if we multiply that by 2 to get 2, because we've multiplied the numerator, the number at the top of the fraction, we have to do exactly the same with the number at the bottom, the denominator. So we multiply 6 by 2 and we get 12. Even though one might look more than the other, they are exactly the same. Looking a bit more at this, if we cut the pie that's been cut into 6ths into 2 halves, you can see that 1/2 is 3/6. How many of the 12ths would we need to cover 1/2? That's 6/12ths. You may notice the pattern here. If you have a fraction that's the equivalent to a half, your numerator will be half the denominator. I've called the numbers here multiplication families. A little bit further up we start calling them common multiples and common factors. We're looking at the relationship between all those numbers. 1/2, if we multiply that 2 by 3, we get 6. Because we've multiplied the denominator by 3, we have to multiply the numerator by 3. So 1/2 is exactly the same as 3/6. To get to the 12ths, we multiply that 6 by 2. Because we've multiplied the 6, the denominator, by 2, we have to multiply the 3, the numerator, by 2 to get the equivalent fraction. So that's 6/12ths. This is one for you to have a go at. Make these fractions equivalent. We have 1/3, so many 6ths, and so many 12ths. Can you fill in the missing numerators? Pause the video, have a go. 1/3 of one of those pies is exactly the same as 2/6. And we multiply that 3 by 2 to make 6, so we multiply the numerator by 2 to make 2. We need 4/12ths to make 1/3. So if we multiply that 6 by 2, we get 12, and if we multiply that 2 by 2, we get 4. Here's a different way of looking at it. Michael and Rashmi each have a bar of chocolate. Both bars are the same size. Michael's bar consists of 9 equal blocks. Rashmi's bar consists of 18 equal blocks. Michael eats 1/3 of his chocolate. Rashmi wants to eat the same amount of her chocolate as Michael. Notice the relationship between the number 9 and the number 18. That will help. How many cubes of her chocolate does Rashmi need to eat to have the same as Michael? Pause the video, have a go. If Michael eats 1/3, he's eating 3 of his 9 blocks. So 3 of the 9 blocks, you can see, covers 6 of Rashmi's 18 blocks. Michael has eaten 3 blocks out of 9. Rashmi, out of 18 blocks, has eaten 6. 6 will divide by 3. 9 divided by 3 gives you 3, and 3 divided by 3 gives you 1. So 3/9 is the same as the 1/3 that Michael had of his chocolate. Compared with Rashmi's 18 blocks of chocolate, if we divide hers by 3, 18 divided by 3 is 6, and 6 divided by 3 is 2. Now that might look different to the 1/3 above, And this is where we start looking at how you can simplify fractions. That means we keep dividing the numerator and the denominator by the same numbers until we can go no further. Both 2 and 6 will divide by 2. 6 divided by 2 is 3, and 2 divided by 2 is 1. And you can see that the 6/18ths of Rashmi's chocolate are exactly the same as 1/3, which is the same as 3/9 of Michael's chocolate. This time we've got a chocolate box, and there are 16 chocolates in that box. 4 of those 16 chocolates have a raspberry cream centre, 4 out of 16. If we look at that chocolate box again and just rearrange the chocolate so it's easier to see the fractions we're talking about, you can see clearly the 4 out of 16. If we take away some of the sections, so we now have 2 blocks of 8 chocolates. Out of each of the 8 chocolates, how many of them are raspberry creams? Pause the video, see if you can work out how many 8ths of the 16 chocolates have raspberry cream centres. So you can see that 2 out of each 8 have raspberry cream centres. So that's 2 8ths, and 2 8ths is exactly the same as 4 16ths. 2 8ths can be simplified further. Pause the video again, see if you can work out what the simplified version of 2 8ths will be. Same chocolates in the same order, but this time I've divided them differently so that you can see that they're in groups of 4. And out of each 4, 1 has a raspberry cream centre. 1/4 is exactly the same as 2 8ths, which is exactly the same as 4 16ths. Looking at this just using the numbers, if we have 4 16ths, because they're both even, we can divide them both by 2. 16 divided by 2 is 8, so we've simplified our denominator. Now we have to do the same with the numerator, so we divide that by 2 as well, and that gives you 2 8ths. We can go further with that and divide the 8 by 2 to make our denominator 4, and then divide the numerator by 2 to make our numerator 1. You could do this the quick way if you're confident with your 4 times tables. You could look at 4 16ths and say, I know that 4 goes into 16 4 times. So I'm going to divide the denominator by 4 to get 4 and the numerator by 4 to get 1. So you've cut out that middle step. As long as you're dividing or multiplying the numerator and the denominator by the same thing, you will have an equivalent fraction. This one's for you to try. 6/30ths. Can you work out the missing denominator and numerator in the next 2 equivalent fractions? Pause the video, have a go. To get from 6 to 3, we divide by 2. Because the numerator has been divided by 2, we'll divide the denominator by 2. 30 divided by 2 is 15. To get from 15 to 5, we divide by 3. Because we've divided the denominator by 3, we need to divide the numerator by 3, and that gives us 1. So 6/30ths is the same as 3/15ths, which is the same as 1/5. Again, you could have done this the quicker way. I know that 6 goes into 30, so I'm going to divide both by 6. 6 divided by 6 and 30 divided by 6. That gives me 1/5.